In this assignment, we'll be trying to model this EndPlate splice connection of vertical braces manually. As you can see on the screen, there is a HEB beam going like that. In the 3D view, you can see it as well. And then there are two box profiles. They're SHS 400 by 400 by 25. They're approaching in such a way that the angle between them is 50 degrees. The working point is the middle of the beam. And there's a plate, if you zoom in over there, you can see that there's a plate between them. You can see the plate over here as well, this plate, which goes all the way down till it hits the web of this beam. And these two braces are then spliced with end plates and stiffeners at a distance of 1 meter from the working point. Now, all those details are given, the stiffeners are given over here, the end plate dimensions are given over here, the location of the stiffeners, etc. The tricky part could be so this is the vertical plate, the plate which is coming out vertically from here. It's got a width of 400, comes down, goes into the flange, goes down, hits the web, comes back up, this little plate over here. And the braces themselves need to be cut like this, as you can see on the screen. So there'll be a cut along this face, which will be along the face of the vertical plate. Then there will be a cut along this line over here, where it's basically sitting on the beam. The first one would be this line over here. The second would be this line over here. But we can't just continue cutting it. We can't just do two fittings, like one vertical fitting and one horizontal fitting, because the flanges have been pushed into so that we have an extra welding length available over here. So therefore, the flange is kind of left to go into the beam with a length of 110 millimeters, like that, like that, like that. So this is going to be the way that the two braces will be cut, and we'll be attempting to do this, to make this connection manually. So let's start by going to the model. I've just created this grid. This can be of any length because that's not of concern to us. Let's just enter a beam like that. The one which will be HEB 400. HEB 400, like that. Let's just rotate it and also bring it in the middle, because this is the orientation we want, middle on both sides. And now because we're going to enter the braces, the better way to do it would be to work on this view of line 1, because you want to look at it from the front. So you go to the view on line 1. Now you're looking at the beam from the side. And the first good thing to do would be to put your work plane in this view. So the X, Y are in that form. And now we can continue with the entry of the braces. So if you remember, the braces were entered something like this, with the angle between them being 50 degrees. So what does that mean? This total angle being 180, and the angle between them was 50. So the remaining angle is 180 minus 50, which is 130. So the one-sided angle from the x-axis would be 65 degrees. So we can use the direct entry method. Let's just go into the vertical bracing command. Let's just snap to the middle of the beam, and then just snap to the same point again. Make sure we're snapping to the same point again. Press enter and say angle 65, let's just give it a length of 2 meters, because there's a splice point needed at 1 meter. So let's just enter a length of 2 meters, and a vertical brace will be created, and we can measure the angle from there to there to there to be 65 degrees. So we've entered it correctly. Now we can, if you remember from the drawing, the profile was SHS 400 by 400 by 25. So we go back to the model. we double click on this, and we find the profile in the database. Go down. So it's 400 by 400 by 25, this one. And middle is fine. So yeah, that's what the profile looked like. And because we will be needing a splice point over here at 1000, what we can do is we can go to the edit menu. In fact, if the length is 2000, we can just break it in the middle as well. So let's just do that. Say break frame in the middle. That should be the middle of it, yeah. And let's just check whether the distance of 1000 is correct or not. Yeah, it's 1000, so we've done it correctly. Now you just select the two and you mirror them across. So you just say copy, mirror. From that point, just give a vertical line, say dy, whatever, 1000, and say run, and you will have the other brace entered up, and the angle between them can now be checked to be 50 degrees. So for instance, we can check that angle. So we can say measure from here to that point, and that's 50 degrees, which is just what we wanted. Now we want to create that vertical plate in the middle. So let's go back to the drawing. And over here you see that the height of the vertical, first of all, let's zoom in. Vertical plate is sitting on the web of the I-beam, and from that point, from the web, the top of the plate, it's 593 millimeters, and the depth of the plate, if we were to see from here, like that. So this one is 593, the height of the plate, and the depth of the plate is 400, and then of course it needs to go inside into the beam, and the thickness of the plate is given as 20 millimeters. So that's what we'll try to do. Just remember the height of 593 and the width of 400 initially. So let's go back to the model. And for this, because the work plane is already here, we're working in this view, we're going to use the sectional plate. And we click on that, and then we right click, because normally that can create a double plate on both sides of an existing plate. That's not what we want. We just want a single plate. So we right click to bypass that. And when we right click, it gives us, it asks us for 2 points. And those will be our points over here. The first point will be on the top of the web over here, from which it's going to go up. So let's select this point. And for the second point, I just hover over the same one and say dy 593, like that. Right click to finish. And I've created that plate. If I were to double click on the plate, you will see that the thickness is by default 20. We can change that. The depth in the other direction is 200. I'm going to change that to 400. If you remember, that was the requirement, but it's a rectangular plate. Don't forget that. Let's just look at it like that. And let's just go in and see what we've done in the 3D view as well. This is what it looks like currently. The plate is rectangular, and it starts off from this point on the web and has a height of 593, and that's what we wanted. It's sitting in the middle, but now we'll need to make some modifications to it. So to continue with the modification of the plate, let's just hide these so that we can see what we're doing better. And remember that this is currently a rectangular plate, and we've entered it using the sectional plate command, which is a macro in itself. And it's basically, if you see, the handles are not the 4 points; they're just 2-point handles, the start and the end. But we want to make lots of modifications to this. So what we need to do in this case is select the plate, click on, press the M key, which will select the macro in the background. Right click and go to macros and say explode. So that this will basically turn it into a normal contour plate rather than a sectional plate. And once we have the contour plate, then we can move the handles around to fit our requirements. So I'll just say explode, and the moment I do that, you will see that the handles change. And now we've got the handles on all 4 sides, and it's become a normal contour plate. So now I can go back to my drawing and actually take a look at what this plate looks like. Right now I have 400 by 593. I don't have all these wiggles which are needed. So to do that, whenever you need, we basically need 2 extra points on this side and 2 extra points on this side, because currently we have only 4 points, but this plate is going to be defined by 1, 2, 3, 4, 5, 6, 7, 8 points. So we need 2 extra points along this line and 2 extra points along this line. So what we can do is we can go back to the model, click on that, and select these midpoints are for inserting new points into the plate definition. So I just select this one, and as long as it says 0, 0, 0, I'm fine. I don't want to give a number. I just say move. And when I say move, you notice that a new point has been inserted, and now we've got an extra one over there. And then I'll choose this one as well and press move again. So now I have inserted 2 points on this side. I'll do the same on the other side, like that and like that. So basically, now I have an 8-point plate, which I can now play with to make it kind of fit into the beam. So now that I have my 8 points in the definition of the plate, I can just note, I can double click on this beam and see that its web thickness is 13.5 millimeters. That's the web thickness. So if I select the plate and I select these 2 edges, this edge over here and the edge on the press control key, and click on the other edge as well, and click on this button over here, which moves edges, and then if I say minus 13.5, which is the thickness of the web, and if I just say move, you will see that the plate has been moved in such a way that these 2 points are over here now. I can look at it like that. That's basically what I wanted. But of course, they're not at the right position. So the next, the insides are now at the right position, but these 2 sides are incorrect. And what I want is for this side to kind of get projected to the surface. So what I can do is I can select this side over here, and I go to this button which says move the edge to the surface. And if I click on that, I can even get an offset to the surface, but I want an offset of 0. So what I say is I select the surface and I select this surface over here. And when I do that, immediately you see that my plate has kind of adjusted itself around that edge. And I can do the same thing on the other side. I can select that, select surface, and then show this surface over there. And when I do that, let's look what happens. If I say show only, the plate has been modified in such a way that these numbers are 13.5, which is the thickness of this length. This one was sitting on the web anyways. So basically, we have what we needed. All I want to do now is give a chamfer, some number, which is what I can do is I can select this point and this point, and give click on this button over here, and give it a chamfer of say whatever 35 millimeters maybe. Hoping that's enough. Yeah, unless it's given in the drawing, I didn't check. But now we basically have the plate the way we want it to be. Let's just say show all, and let's just turn these ones off again. Yeah, there you go. The plate is now correctly positioned where it needed to be, like that. So when I look at it from the side, I realize that I've made a mistake. I was actually I should have used the flange thickness to pull this line back in, but I mistakenly used the web thickness. So actually the flange thickness is 24, it's not 13.5. So I made a mistake of about 10.5 millimeters, and I can see that with the vertical lines of this plate. They should be further, another 10.5 millimeters. That's easy to correct. You just select this edge from here and press Control and select this edge from there, and give it a further minus 10.5 so that it becomes 24, the total, like that. And now basically it is where it was supposed to be. There you go. Now the plate is exactly as it was meant to be. There's 24 millimeters inside, goes down, does a chamfer around. If I wanted to see whether this chamfer is enough for this profile, because I can't see the radius over here, so I'm not sure. But what I can do is I can select this beam, right click and say go to frames and say draw exact shape, and that will temporarily draw the radii on both sides, and I can see whether I'm clearing them, and I am. So I'm good with that. Now let's think about the cuts. We need to cut these braces, and if we go back to the drawing, we see that it's a pretty complicated cut. Had it only been a vertical cut like that and a vertical cut like that, and this flange, had it not been intruding in, going into the beam, it would have been much simpler. For example, in that case, what I would have done would be go back to the model, and in this view, I would have gone to my plane cut with a surface command, select this brace, for example, and then now it's asking for a surface. I want this outer surface, so I just get close to that, but it's selecting the other one. It's selecting the one which is facing me, so I can't seem to select that. So what I do is just hover over that point and I click on the control key. When I click on the control key, it's going to toggle between this surface and the other one. So I'm clicking on the control key now, and you see that it toggles to the other one. And if I click on the mouse button now, it'll create a vertical kind of a plane cut for me. And then I can do the same. I can select the same one again, and this time I want the top surface of the beam. Once again, I can't select it, so I hover over it and I click on the control key, which toggles to the other one. And now I click the mouse button, and there we go. We basically, in 2 clicks, managed to. So let's see what we've done. Let's go in there, go to the 3D view. What we've done is, if I select this one and say show only, this is what we've managed to create with just 2 clicks. But the thing is that this is not what we want, and it's a bit more involved. It is right now cutting, it's not clashing with anything, this one, but what the detailer wants is for this flange or this part of the box to actually extend into, if you go back to the drawing, you will see this little extension, which we can see over here as well. Over here we can see it, that this flange is actually extending into. So this is going to be a really complicated cut, and that's the purpose of this assignment too. We end up doing about 4 cuts to get what we want, not just 2. And what we realize is that while we can use this one, but we can't use this fitting because this one will just slice it through. So we'll need to use a fitting over here. We'll need to use a polygon cut over here, and then 2 further polygon cuts to further shave off those flanges. So now let's attempt that difficult cut. So first of all, we can keep this one, but we can't keep this one. This one will need to go, so I'm just deleting that. And so we've got this side shaved off, but this side we know needs to go in 110 millimeters. So what I'm going to do is I'm going to first create an extension point. I go to the extension point command, click on the shift key to open the settings, and give it a distance of 110. Then I just snap on any point on this line, or press Control to snap on it, and then snap to this point, so that it gives me a point which is 110 millimeters from that. So if I right click, go measure from here to here, it's 110 millimeters. That's the first thing I'm going to do. Now, as a general rule, always remember that it's always a good idea to never create your cuts in a way that they're shaving off at exactly where an element is ending. So it's always a good idea to keep a few millimeters away from the exact edges. So what I would do over here is I would go to my parallel points command, click on the shift key, and maybe 25 is fine actually. And if I just select this point and this point, I can get a parallel line over here, and then I can come down over here to get my cut. what I can do is I can do an intersection between this line and the bottom line. Just follow me on this. Do the intersection points between this line and press the control key for any 2 points on this line. And I have my point over here as well. Now what I'm going to do is I'm going to now create a polygon cut. I'm going to go to my cut commands and say polygon cut. I'm going to select this element, and then I'm going to say I'm going to start off from here, for example. From here, go to here, and then go across, perpendicularly across to that point. Then go to this point, then go across to this point, and come down all the way to this point and go back to the starting point. And that's going to basically cut off this part of the brace, but leave this this part untouched. And we need to see what we've done. So if you notice, if you come to the 3D view and you turn off the cuts for a second, you will see that let's just say show only. So we have managed to achieve something. We have managed to have this extension going in. This side is cut, that side is cut, but there's still a problem. If I say show all, there's still a problem, and that is you can see that this flange of the box section, or whatever you want to call it, is still clashing with the two sides of with the two flanges of the main beam. You can see that because of this. You can see the projection over here. So we need to like shave off a bit over here and shave off a bit over there. That's two more cuts. We can actually do that with using a part cut as well. So if I wanted to, I could just say now if I went to my cut command and said part cut like that, and I said just cut this part with this part, that's basically going to do it. If you notice now it's gone, that little thing has been shaved off. And if I said show only, you can see that now it's not extending, and this part you will see if I go and measure the distance, you will see that this part will be 110 millimeters, just like we want. So actually this is the result we want. But when you do part cuts, just remember that the cut is going to be the exact same shape as the profile which you showed as the cutting part, and that's going to make life a bit difficult later on, because right now over here there's if I select like that, I'm selecting. If I press enter, I'm selecting the profile. But if I need to select the cut, I need to be so what the option I have is I can go like that. Select both of them, press enter, and now it says you've selected a profile and a cut, and I can click on this one and click over here, and now I know that I've selected the cut. So when you're using part cuts, I recommend that immediately after using it, you shorten it to just because it doesn't need to be this long. You use that beam to cut it, and it's 6 meters. You can see the handles over there. The length of the cut is the depth of the cut is 6 meters, which is basically the same as the length of the beam. But we don't really need that much. So what you can do is you can just select the cut like I just did. Press Control to select the part as well, which you'd cut, and right click and say Show Only. And now you see that the cut is going all across the beam. And then you click on the cut, really reduce this number to some bare minimum number, maybe 200 millimeters, say apply. And when you do that, it's going to shorten, but it's not at the right place now because it previously was going all along the length of the beam. Now it's there, but it needs to be moved a bit in the X direction. So what you can do is you can select it and right click and say move, and maybe in the X direction, if you can just select these 2 points, that's about 144 in the X direction, make the others 0, and maybe make this a bit bigger, maybe make it 170 or something, and you just say move. Okay, that's not enough, let's move it a bit more. I chose the wrong point. There we go. that should, so now if you notice, if I turn off the cuts, we basically achieve the same result. But this time, if I say show all, and even with the cuts turned on, I can select the beam, and if I zoom in, I can select the other cut as well, because they're not exactly overlapping. Now that we've got the cut where it's in a better position than it was, we can just go do a window selection, select all the 3 cuts like that. So we've got the 3 cuts selected, but they're all cutting the right brace, and we can just say right click, copy, mirror, and zoom in, and this is the mirroring line. I think it's already defined, but I'm just doing it to be certain. And once I do that, I can click on the run button over here, and the 3 cuts are mirrored to the other side, and they've automatically found the new dependent, which is the new brace. And we can see that. We can go to the 3D view, and we can select this one and say show only, and we see that this one is also cut just like the other one. Let's show everything and turn off the cuts, and basically you can see that the basic structure of the connection is there now. The flanges are going in by a length of 110 millimeters. We can check that again from here to here. It's 110 millimeters. And what we are left to do now is basically create the end splices. So now we return to the end plate splice itself. We notice that the end plates, the thickness of the end plate is given as 30 millimeters, and the middle line is 1000, which we've already done the break at that point. So the 30 millimeter thick plates, and the size of the plates is 660 by 660. It's a square plate, just like the sections are square hollow sections of 400 by 400. So 660 would mean another 260 extending. So divide that by 2. So it's basically extending 130 from each side of the hollow section. So just remember these numbers. 660 by 660 is the plate size. And what we can do is we can go back to the model. We already have the work plane over here. We can go to our steel command, go to the sectional plate, just like we did in the beginning. Click on that, right click. Use these 2 points to create a plate. Right click to finish, and then click on enter. The depth should be 660, and the extension, because we've used these points because they were available, the extension should be 130. So this needs to be entered as -130 over here and -130 over here, like that. And the thickness should be 30 millimeters. If we use that, we say okay. So we basically we see that we have the plate like that. What we can do now is go back in once again, and I'm not sure whether it's this one or this one. Let's see. Let's try this one. Yeah, that's the one. So this behind will basically make it go up, and then the other one which we'll create, we'll use the other option of front. So we've created one plate with a thickness of 30, 660 by 660. We can just check that as well. We can go to the 3D view like that. You can see one of the plates has been created. And now we can go in and create the other plate by using the same method once again. Just go back to the sectional one, right click, use the this point and this point like that, right click to finish, press enter. Once again, we can either do match elements as well, make this 660, make this -130, this one -130, and instead of behind, let's use front this time, and there we go. So we've got the 2 plates in, the 2 30 millimeter thickness plates. We can check them out in the 3D view. There we go. They're exactly the way we want them. And now what we can do is we can cut, or we can pull back actually. That's also possible. One way to do that would be to actually give the end offset. So this is the start and this is the end. Since the thickness of the plate is known to be 30, we can double click on this box profile and give it an end offset of -30. That would do it. That would basically bring it to the face. And as far as the other one is concerned, it's the start. The yellow denotes the start and the pink denotes the end. So it's a start, so we can give a start offset of 30, like that. And so we don't really need to cut. We could also have used a fitting or a cut over here, but when it's a linear thing, it's preferable to just use offsets. So now we basically have the, and we can do the same. So this one is pink as well. We can, while we're at it, we can just modify this one as well to give it an offset of -30 at the end over there, and this one would give an offset of 30 at the start, like that. So just that they're ready when we eventually copy or mirror these to the other side. Those offsets will be ready. So we've got the plates ready now, and now what we need to do is create the bolts or the stiffeners, or whichever one we want to work with first. So let's start with the bolts, if you will. So we see that this is the end plate, and we've got 5 holes over there, 5 bolts on this side and 5 on this side. They're symmetric, and then 3 on this side and 3 on this side, and they're also symmetric. And the notes will tell us that all bolts are M30 and the holes are 33 millimeters, so we have a 3 millimeter tolerance. So these 5 bolts are over here along the depth. These 3, which we are seeing over here, are these 3. And then once again, we see the 5, and then it's the other side. So the distance between the bolts is always 120, 120, 120, 120, and they are offsetted 65 millimeters from the edges on both sides. The distance, it's only the number of bolts which is different. 5 bolts, 65 offsetted, distance between them 120. Similarly, 3 bolts, offsetted 65, distance between them 120. So with that in mind, we go back to the model. And when you're dealing with bolts, because you might need to move them around, it could be a good idea to set your work plane to the surface, maybe this one. So you basically you're on that surface. And what you could do is now you could basically go to your bolt command and say bolt with auto coordinate system, or bolt because you've already set the coordinate system. But I prefer using, when there's plates involved, it automatically calculates the coordinate system. So select that, select the first plate, select the second plate, right click, and then select the midpoint. I'll tell you why in a second. Midpoint, and just select the next direction, like that. And it's going to create, if it can, on the, sometimes it'll create them like you see them right now, or sometimes if there are tolerance issues, you might see green lines showing that it can't find an intersection. But what I'm going to do is I'm going to select them, and since I know they're offset at 65 millimeters, I'm going to, and in the -x direction, I'm just going to say move linear, reset that. In the y direction, in the x direction, I'm going to say -65, like that. Close that, and now double click on the bolts to make the modifications, turn that into an M30 bolt. Go to the settings, increase the bolt tolerance to 3 millimeters. Go to positions. The X position, I'm going to say 5 multiplied by 120, like that. And it's going to go like that. But then I'm going to do the X alignment as middle, and it's going to middle those bolts to the coordinate system which I chose. So basically, I've chosen 5 into 120 because there were 5 bolts, and I've chosen the middle option, and that's basically gotten me the bolts. What I can do now is I can mirror them once again. I can select these bolts and mirror them to the other side. Let me just go back to the 2D sectional view and put my work plane over here. Select my bolts, right click, go to copy special mirror. I think the mirroring plane is already there, so I'm not going to check it. I'm just going to say run. No, actually, I should have checked it because it's not this. This is not the mirroring plane. I'm going to mirror this bolt to this side. So my mirroring line is this one, the center line of the brace. So let me just do that again. Right click, make sure my work plane is over here. Right click, go to copy, go to mirror, and this time choose this line. I didn't choose this line. I just used the one which was previously set, and obviously that's not the one I want. and I click on the run button, and my bolt will be mirrored to the other side. I'll be able to see that in the 3D view. There you go. Let's just close this. So I've got my 5 bolts on those two sides. And what I can do now is I can just once again put my work plane to surface to this one. Go to my bolt command again. Click on this one, right click on this, but the origin point and the X direction. This is going to give you this error sometimes. Previously it didn't. It's a tolerance related thing, but that's fine. There's no issue. It's basically because it's right on the edge. The points I've selected are right on the edge. So sometimes it finds the material, sometimes it doesn't. We're going to move it inside anyways. I just select the bolt and say right click and say move linear in the Y direction, 65, as you know, like that. And this time it finds the bolts, it finds the material. Rather, once again, I change to 30 millimeters, change the tolerance to 3 millimeters, and then go to the positions. And this time it was 3 into 120, like that. And I also keep my X alignment, bring it to middle, and those are my those would be my bolts, like that. Now, what do? I can mirror it across to the other side as well. That would be one way of doing it. But for that, I might need to use a different view, because this view will not probably not work. Let's see. You can't mirror this bolt to the other side using this view. So that would be one way of another way of doing it would be to actually use another view. Or what I could do is I could rotate as well. So what I could do is I could select these bolts, and my work plane is like this. So I could just right click and say copy, rotate, and then click on this point and right click. So my rotation axis is that. And if I do a 180-degree rotation, if I do 180 degrees, and if I say run, I'll probably get my bolts on the other side. So you see I've got my bolts over there, I've got my bolts over there, like that. And basically the whole thing is ready now for the stiffeners. Now let's talk about these stiffeners. They're over here, 12 millimeter thickness. This 200 length is along this side, and the 130 is basically this up to the edge of the plate. So just remember these numbers: 200 by 130 and 50 millimeter chamfers, and a 12 millimeter plate. So if you go back to the model, what we can do is we can go to the plate. First of all, we can put the work plane on this top surface. That would be helpful. And then we start off with the plate command, and we can, let's say, hover over this point. And so this is the X direction, this is the Y direction, and therefore the Z direction is upward, perpendicular to that, in the upward direction. So I want my this length to be 200 and this one to be 130. So I can hover over this point and say DZ200. Or was it 200? Let me just check first. Yeah, it is 200 by 130. So we go back. We can go to the plate command, hover over this point, say 200, DZ200. So I snap to my first point. I can come down and now snap to this point. Then I snap to this point, which is actually 130 away. But if I didn't know that, I could just press enter and say just 130. And that would be in that direction, but it's the same one. Now I need to go up 50. So I'll just say DZ50. Then I will need to come not to this point, but 50 away from that point in the X direction. So I'll hover over that point and say DX50, like that, and then just close it. And I create my stiffener. If I double click on it, I can make the thickness 12 millimeters, like that. I can put a chamfer if I want over there, like that. Let's make it 25 millimeters, for example. And then I can, so let me see what the distance between them is. The distance between the stiffeners is 120. There's 3 more on that side. So we go to the model. This is the Y direction. Copy linear in the Y direction, say 120, and give it 3 copies like that. So we have the 4 stiffeners, and now we just need to move the whole lot. Let's go back to the drawing and see that the stiffeners are such that the middle of the first stiffener is 150 millimeters from the edge on both sides. The middle of the stiffener is 150 millimeters from the edge. So all we need to do is just select all 4, right click, say move linear, and then just remembering that this is the Y direction in which the move needs to take place. We just go to select the middle, and the middle needs to be 150 from this edge. So we hover over this edge and press enter and say dy 150. That will give us the net movement, which is 20 millimeters. And if you just say move, the stiffeners will be centered the way they are in the drawing. Now, if we notice that these stiffeners are actually perfectly symmetrical around all 4 sides, we can think of a little trick. Let's go back to the model, select the stiffeners. The work plane is on the top surface. If we just say right click and say copy rotate, and we select this point, right click, it was already selected. And now if we do a 90-degree rotation, 1, 2, 3 copies, we should be able to get the stiffeners on all sides. If I just say run, that would basically give me my stiffeners on all 4 sides. And if I were to now, actually the requirement, the assignment doesn't really require this because we don't have stiffeners at the bottom. But we could, let's say, for the sake of completeness, want to copy the stiffeners on the bottom side as well. So what we could do for that would be, we could just select the plates like that, enter, go to the plates, select go by thickness, go to plates rather, and select the 12 millimeter ones. Those are the stiffeners. We have them selected now. And now we can go to our, let's see, where is the other? Yeah, this is the view. And in this view, we can mirror them around this middle line. So we put our work plane in this view now. The stiffeners are selected. Right click, and if we say copy mirror, and we select the middle line like that, and we say run, we'll get the entire set on the other side as well. Let's go back to the 3D view, and we now have the stiffeners on all sides of the connection. Now to go back to the model like that, and now if we select everything like this, so we've selected the stiffeners and the plates and the bolts and everything. What we can do is we can just mirror around this center line, and we should hopefully get the same connection on the other side. So let's do that now. We've selected the stiffeners and the bolts and the plates, and we can just go right click, copy, mirror, and this time with the work plane in this view, we choose the middle line, the top and the bottom. So that would be our mirroring plane, and if we just say run, we will be copying the whole thing on the other side. And now we can go back to the 3D view, maximize it, and we can proudly present what we just did, completely manually modeled with a very complex cut, with the middle plate, with these 2 end plates, the corner stiffeners, the bolts, and everything. So a complicated connection, but if you notice, we've been doing this like, I don't know, for maybe 35, 40, 45 minutes. But that's because we've been explaining everything at every level. But in reality, if you were to sit down and quickly do it without talking to anyone, you'd probably be able to do it maybe in 10, 12, 15 minutes. So give yourself that kind of a target when you're dealing with a complex connection like this as well.